Okay, this is your prior knowledge before we start chapter 3. So everything we're doing today should be review from stuff that you've done before, but are going to be used in chapter 3. So part I says for numbers 1 through 4, consider the algebraic expression 3x plus 4. So we're going to be looking at this and state the following. How many terms are there? So terms are numbers or variables inside the problem. So I have one term right here, two terms. So there are two terms. State the coefficient of the algebraic term. So the algebraic term is always the one that has the variables in it. So right here, 3x is the algebraic term, and the coefficient is the number that comes in front of the variable. So the coefficient here is 3. What is the constant term? Remember, constant term is a term that will never change no matter what x is worth. So your constant term is the one that does not have a variable with it. So in this case, it's the number 4. And then write the operation symbol. Here I see, there's actually two. I see addition, that's the obvious one. But there's another one, we just don't see it. And that would be between the 3 and the x, we would multiply. Okay, so for part 2, it says complete the table, show your work. So I'm going to tell you what x is equal in this column, and across the top are some different algebraic expressions. So this looks very similar to your evaluating expressions puzzle that you did the other night. So you can see x plus 9, when x is 0, I would rewrite that as 0 plus 9, and that equals 9. So 7x, I would rewrite that as 7 times 0, because remember, a number next to a letter means to multiply. So 7 times 0 is 0. If I was using 5x minus 2, then I would say 5 times 0, because remember, a number next to a variable means to multiply. So 5 times 0 minus 2. So 5 times 0 is 0 minus 2. That would be leave, change, opposite. And I would get negative 2. Kind of ran out of room in there. Okay, so let's try it again. This time x is going to be worth 2. So x plus 9 becomes 2 plus 9, which I know is 11. 7x becomes 7 times 2, which I know is 14. 5x minus 2 becomes 5 times 2 minus 2. Order of operations would have me multiply first, so 5 times 2 is 10, minus 2 is 8. Now, these have a star by them because you're going to try these on your own, and then there's a Schoology answer document that you're going to put your answers in. It's in the file folder for today. So you try these two on your own. You can pause and try them now if you want, or you can come back to them at the end of the video. Section 3, numbers 6 through 9. Can the expression be simplified? Explain your reasoning. Okay, so we're just going to say yes or no. So number 6 says 2k minus 3 plus k. Can this be simplified? Yes, it can, because I have some like terms. I have 2 k's in there. So I would just say yes. I don't actually have to simplify it. I just need to say yes or no. And it's yes, because I have 2 variables that are the same. Okay, I'm skipping 7 and 9 because those are the ones you guys are going to do. So let's go down here to 6u plus 5w minus 1. Can this be simplified? And the answer to that would be no, because we don't have any common variables. Here we have a u, here we have a w, and here we don't have any at all. So those cannot be combined. That's in its simplest form. For section 4, numbers 10 through 13, it wants us to simplify the expression. So again, 11 and 13, I'm leaving off because you get to do that yourself. So I need to simplify what I can. And when I look, I see 4t right here. So I'm going to box that in. Anything with a t, I'm going to box in. That's the only thing. And then over here, with my whole numbers, I'm going to circle anything that has a whole number, including the sign in front. That's what we do here in 7th grade. We circle the sign in front also. So it says 4t, okay, 4t, and then 1 plus 6 is 7. So that's going to be a positive 7. So 4t plus 7. You always should write the variables first and then the constants last. So number 12, I'm going to circle the 4y, or box it in, sorry. I'm going to box in the plus 5y and put boxes around both of them because they both have y's, so I know they can be combined. I'm going to put a circle around my plus 3 because that's the constant. So I can combine those. 4 plus 5 is 9y. And then I can't combine this plus 3 with anything, so it comes along at the end. 9y plus 3. Again, we write our algebraic term first, and then we write our constant at the end. Okay, let's flip it over to the back. For numbers 14 through 17, expand the expression. Use the distributive property. You learned that last year at HPI, the distributive property, and we're going to use it a lot again this year. So again, 15 and 17, you get to do and put your answers into Schoology, and we'll do these two on our own. So distributive property means we pass out everything on the outside of the parentheses to everything on the inside of the parentheses. So I would say 4 times h is 4h plus 4 times 2. 4 times 2 is 8. So my answer should be 4h plus 8. Okay, let's try it again. I need to distribute everything on the outside of the parentheses to everything on the inside. So I still draw these arrows. Even as an adult and doing these for years, I still draw the arrows to make sure I hit everything. So 3 times 4 is 12. X minus, bring down my sign, 3 times 11 is 33. And that's my expression written in expanded form. This should be section 6, but section 7, numbers 18 through 21, it says factor the expression. So again, these two with the star you're going to do on your own, and those are the last two you do on your own. So factoring is basically the reverse of what we just did. So when we factor, I always have you write the expression again like this, and I make you do a factor ladder. And you don't have to take out just a prime number. You can take out any number. So I'm going to take out the biggest common factor that I see is 3. So 6 divided by 3 is 2. Bring down the variable, the plus sign, and then I do it again. 3 divided by 3 is 1. So what's lovely about this is this number on the outside, that's what goes on the outside of my parentheses. And this at the bottom, that's what goes inside my parentheses. And that's why I like to factor with a factor ladder, because it makes it really easy to write my answer. The number on the left is what goes on the outside of the parentheses. What is at the bottom goes inside the parentheses. Let's try this again. 10p minus 2. 10p minus 2. Okay. Greatest common factor of 10 and 2 is 2. 10 divided by 2 is 5. Bring down the p minus 2 divided by 2 is 1. So again, this number on the left, that's what goes on the outside of the parentheses. And what's at the bottom, that's what goes inside the parentheses. Section 8, number 22, multiple choice. Which expression is equivalent to 6y minus 3? So I'm given 4 different choices, and I have to figure out which one's equivalent. Looks like I need to distribute all of them. So I'm going to say 3 times 3 is 9y. And I look, and I know right away it's not going to be this choice because it needs to say 6y. So I'm going to go to the next one. 3 times 2 is 6y. Okay, so far they match. Minus 3 times 1 is 3. Oh, I don't even have to go any further. I know my answer is going to be B. Okay, this is the part that's tricky for a lot of people. So this is section 9, numbers 23 through 26. X is an unknown number. So we're going to use X to represent our unknown number. Write an expression for the following. This is called translating an algebraic expression. It's really hard for 6th, 7th, and 8th graders to visualize. So we're going to work on this a lot. Okay, it says 7 more than a number. So I always circle my important either numbers or variables. So it says 7 more than a number. And I underline the operational words. That would be more than. Okay. So I know I'm going to use 7. And remember, my unknown number, the a number, that's going to be represented by x. And I got to figure out what to do with them. So it says 7 more than x. So more in math would mean to add. And than is what we call a turnaround word. Now, in addition, it doesn't really matter because remember, addition can be done in any order. But subtraction, it is important that we write it in the same order. So we're just going to keep talking about the word than so you remember. So what does turnaround word mean? That means normally you write an expression in the exact same order that you see it in. That you would normally say 7 plus x because 7 came first, then the plus sign, and then the a number, which we said was x. But when we see the word than, it tells us to turn that around. So it becomes x plus 7. That is saying, if I had 2, 7 more than 2 is what? So 2 plus 7. Okay, so let's try this again. Product of 8 and the number. Okay, so I circle my important numbers or variables. So I have 8 and the number, which we know means x. Okay, and then we have the word product. And by now you should know that a product is a multiplication problem. Okay, so product means multiply, and I'm going to multiply 8 and x. So when we do algebra, we just put the number and the letter right next to each other. Don't put a sign there. Don't put a dot or a little cross. We just write 8x. We really need you to get in the habit of doing it the correct algebraic way. Okay, number 25. 5 less than twice the number. So I see 5. The word twice means the number. And the number. So what does twice mean? Twice means 2. And the number we remember is x. And I see words less than. So less I know means to subtract. And than I know is what we call a turnaround word. So it's saying we have to switch the order. So I want to say 5 less than twice means 2 times the number. And we would say 2x. But because of this word than, that very, very, very important word than, it switches the order. So this actually is completely incorrect because it's a subtraction problem. You can't reverse the order. I would need to say 2x minus 5. And it's okay to write it like this the first time and then flip-flop it around. Just make sure that you understand that this is your final answer. If you were to plug a number in here for x and you had it this way or this way, it's going to be different. For instance, let's say we said x equals 2. And if I did it this way, I would say 5 minus 2 times 2. Okay, an order of operations would tell me to multiply first, and I would get 1 as my answer if it was written this way. If I do it this way, I would say 2 times 2 minus 5. Again, multiplication would come first. 4 minus 5, well, that's a leave change opposite, and I would get the answer -1. So see, with subtraction, the order does matter. This is the way we want it. That word than switched the order that they needed to be written in. Okay, number 26, last one. 3 more than half the number. Okay, so half. I'm going to write it as a fraction, and the number I know is x. Okay, then we have keywords, more than. So again, remember addition, technically we can write it in any order. So saying 3 plus, that's a plus, more is plus, and than is a turnaround. So 3 plus 1/2 the number, that means half of x. So I could write it this way, and I would not get it wrong, since addition can be done in any order. But if you're really following it, where it says than, and it means I need to switch my order, then really I should write it like this. 1/2 x plus 3. I just took these two and I flipped them around. All right, so these, you don't have to do any of these on your own. Obviously, we did them all together, but that's going to be the focus at the end of our chapter. And if you feel really uneasy about these now, hopefully by the end of the chapter, you're going to feel a little bit better because we're going to keep working on it. So now it is your job to finish the ones that I put a star by, try them on your own, and put your answers into that Schoology assignment.